here is an example of why polar equations are so helpful. As you can see, you have this satellite going around Earth here, and we have this theta and this radius. The radius is going to change the theta of how many times it's going around, which is obviously going to be closely related to trig. So you're going to see a lot of trig in this, especially here and here. But that's basically the power of polar equations to begin with. I'm not going to really stress that so much because this is a calculus class. The main thing is, can you find the derivative, and can you find the derivative at certain points? Okay. One thing I do want to point out, and I should have talked about this a little bit more in the parametric. If you look right here with the equation, the dt's on these are both going to cancel out. So you end up with dy over dx. It's actually the same thing that's happening over here with the d theta. Okay, the d theta would cancel out. So that's why you can just do the derivative of y with respect to theta and the derivative of x with respect to theta and divide them out, and it still works because those cancel out. Okay, so your function is based on a radius. Granted, this isn't a radius of a circle because this is like an oval here, an ellipse, I should say, but you get the idea. Let's do an example using this formula, and then we can move on from there. Let's see here. Okay, so the first example we're going to use is, let's do, if r theta is equal to, let's do 2 sine of 3 theta. Okay, I want to know what is the derivative of y with respect to x, just in general, and then I'm going to plug in specific values. Let's just do at theta equals pi over 6. I think that's what I used last time. This is supposed to be an at, like an email. All right, anytime you see polar differentiation, which is the only time I guess we're going to do some integration stuff with it, but if you see polar differentiation, it says the derivative, right away I would just take the derivative of r with respect to theta. And this is a good review of chain rule here. Okay, so you have to do the derivative of this right here, and we need this in the formula over here. It'll make more sense as we go. But let's find r prime of theta. So it's going to be 2. That's a constant multiple, and then you have to do the derivative of this sine, and then you wait for the n to multiply by the inner derivative. If you remember chain rule, that's a composite function. We have this function on the inside of it here. So we're going to do the derivative of sine first, which is cosine. The inner layer stays the same as 3 prime, and then you have to multiply by the inner derivative. The derivative of that is going to be 3. So your final derivative for r prime is going to be 6 cosine 3 theta. This should be nothing to you because you've seen this before. Like, this should not be difficult. If it is, then you are definitely going to want to review chain rule because it's not going to go away anytime soon. It's going to be used extensively in further units as well. So definitely review that. It's not just a one-time thing. So we have r prime of theta. Now, the formula states that we need y prime of theta and x prime of theta. Okay, so let's just start with the dy over d theta here. So now we have to do the derivative of y with respect to theta. Well, y is equal to this part right here, r sine theta. So we have to do that derivative, which means we have to use product rule because we have a function r times sine theta. R is a function right here with respect to theta, and then so is the sine theta. All right, so to do product rule, you have to do f prime g. So you have to do the derivative of r times regular g, which in this case it's sine theta, plus g prime, which is cosine theta, times r. Okay, now you can see why we need r and r prime because r prime shows up right here and then r shows up right here. So we're going to need those. Okay, and then we're going to do the same thing with x. We're going to do the derivative. X is r cosine theta right here. So you have to use product rule. So it's f prime, which is r prime, f prime g, plus g prime. G prime is negative sign, so I'm going to put a negative there. F, so I'm going to put an r there. Okay, I mean, these are always going to be the same. These are always going to look like this every single time because x and y are always going to look like this. So the derivatives are always going to look like that based on it. All right, the derivative for this would just be this top one divided by the bottom one, but I just want to find the derivative at a specific point. So I'm not going to worry about, I mean, you could just put a divided by sign here and here, and you get the answer. But we're looking for mostly the derivative at pi over 6. So what I'm going to do is plug in pi over 6 to all of these terms here. So r prime of pi over 6 is equal to, we need the r prime equation with the input being pi over 6. So now you're going to have 6 times cosine of 3 times pi over 6. Okay, so then the 3 and the 6 cancels. You have pi over 2. Cosine of pi over 2 is what? 0. So we know this one here. We know this one here. Now we do sine of pi over 6 because you have to put theta in for that. So let's just start writing this down. So dy over dx is equal to, wait, why am I doing that? It's 0. This is embarrassing. This is 0 and this is 0. So that's gone, right? Because r prime is 0. So this is 0 and this is 0. It doesn't matter what sine theta and cosine theta are. So all we need to do is worry about r cosine theta divided by negative r sine theta. So r of pi over 6, should do that one really quick, is going to be equal to 2 times sine of 3 times pi over 6. Based on this up here, this is our r equation. This is pi over 6. Jeez. All right, oops, wrong color. All right, so this is going to cancel to be pi over 2. Sine of pi over 2 is 1. So you should just get 2 for this. So now it's going to be equal to 2. These are both 2. 2 cosine of pi over 6 divided by negative 2 sine of pi over 6. Okay. The 2's are going to cancel. So you're going to be left with negative cosine of pi over 6 is what? Anybody? There you go. Root 3 over 2. And then, yeah, 1/2 here. Okay, the divided by 2's cancel. Divided by 2 is 1. So then you get negative root 3 as your slope at that point. This is not as fun as parametric because you always are going to have product rule. Product rule takes a little bit. Also, people don't remember the unit circle, so that takes a little bit. Okay, take out your calculator. I'm going to show you how to do this on your calculator to spit out the answer. Again, it will spit out the exact at the point, but it will not actually spit out the derivative itself. On your calculator, hit mode. And instead of parametric, go to polar. Get rid of that. Let's do 2 sine, was it sine? I think so, 3 theta. If you notice when you press the X button now, theta shows up. That's why it's that third, it's X comma T comma theta. That's why it's there. So we have something like that. We want pi over 6. So as long as that's 0 to 2 pi, that's fine. And I'm going to do zoom 7 because it's zoom trig. It just fits it to the screen nice. And you end up with that cool looking thing. Okay. Now we want pi over 6. So I'm going to do second calc, the derivative. So we want 2 of pi over 6. And if you notice right here, the derivative is as negative 1.732051. If you know the square root of 3, let's see here, square root of 3, I forgot to make it negative, but it's equal to that same value. So it kind of shows you that you did it right. On a quiz, if you were allowed to use your calculator, you would have to still, your answer that would be accepted as root 3, not this decimal approximation. One way of making this a little bit more complicated, it's not that much more complicated, but it might say like, what is the equation of a tangent line at pi over 6? So what if I was doing the equation of a tangent line at theta equals pi over 6? Okay, so that means we need a y equals mx plus b at pi over 6. Okay, so we know the slope is equal to negative root 3. We just need to figure out the b. To figure out the b, we need the x and the y. To figure out the x and the y, we have an x and a y equation. Just as a rule of thumb, engineers, computer scientists, chemists, physicists, who whatever your major is, try to look for the equation that you actually need. Sometimes people go, oh, x and y, I don't know how to find that. Well, look around. There's an x equation and a y equation right there. And if you look around and you can't find that equation, look for something that can lead you to that equation. Okay, what can get me the x and the y? Okay, a lot of times the stuff's right in front of you and people go, I don't know how to do it. And they ask a teacher a question and then the teacher's like, how do they not know where it is? It's right in front of them. A lot of people aren't trained to like actually look for it. So we need the x and the y at pi over 6. Well, we actually found that out over here. Well, not the negative. Okay. So the r, what was the r? 2. Yeah, 2 right here. So the r was 2. So to find the, let's do the y first. It's going to be 2 times sine of pi over 6. Okay, we did that right over here. Except we have the negative in there. So it's going to be 2 times 1/2. So you're going to end up with 1 there is equal to root 3 times x. Well, the x is going to be, it's going to be 2 because x is equal to r cosine theta, cosine of pi over 6. Pi over 6, cosine of pi over 6 is root 3 over 2. So this is just going to be times root 3 plus b. Okay, this whole thing's going to become negative 3. That's embarrassing. B is equal to 4. So now your final equation of a tangent line is going to be this. Like that.